Welcome back. Greetings. Thank you very much for coming in. Today, and in this session, I'm going to talk about session 6, the final segment of the slides on data preparation and data preprocessing. Data comes in different formats. We have 1D, 2D, and 3D images and signals and numbers that are coming at you. One of them, of course, is image. And today, we just want to introduce you to some of the terminologies. One simple, extremely simple component of image processing. So this is not going to be a comprehensive topic that we have. So please keep in mind, image processing is not a single course. It's actually a field of study. I would say if you wanted to have in-depth knowledge of image processing, you would potentially need to take something around 8 to 10 different courses. It's really big area. It's not just a simple. So we do not have that capacity to talk about image processing and techniques used and different approaches to image processing. We just want to introduce this concept to you, and the rest, of course, you have to wait until the advanced courses are being offered, or perhaps you can actually search on Google and get more education on that part. If you take a look at an image, this is a famous image, and you can see that these images are the same, exactly the same, except that information that is available in each image is different. And the reason it is so is because of the filtering that we have applied. So you have an original image, for example, 10 megapixels. Remember, we spoke of pixel in the past when we talked about images and the way images are represented. We talked about pixels. We talked about vector-based images. This is pixel-based. So the camera you have most of the time, it would be pixel. So you have a camera which is 20 megapixels. And each pixel is going to be represented by the level between 0 and 255, from gray to different colors that you can imagine. Now, this is a black and white, I would say. And if you take a look at these images, as I said, they are exactly the same. Nothing has happened at the background, by the way. But if you take a look at this, it looks like as if there is a huge sunlight at the back. It's not. It's just the effect of filtering process. If you take a look at this, you could potentially identify different information. For example, if you take a look at these perhaps pebble stones, you can see that they are very sharp. I would say the pebble stones are quite nice. You can see that. I may have made a mistake considering that this is actually grass in the front yard or in the field, a green grass. So please keep in mind that based on the filtration you are going to do, you're going to actually get different pieces of the information that you need from the image. So this is an image. Potentially you are not interested in the coat of this gentleman. You don't even see the hand. Here you are going to see the hand and even the glove. The glove is less visible here, and even more so less visible in this case. What are you looking for in the image? And that's a very important question. And you need to basically find the appropriate filtering and the appropriate approach to extract the information that you want from the image. One of the things that I would like to discuss in this piece of recording is about compression. So take a look at, for example, and compression is one way of filtering anyway. Imagine you are taking a cell phone and you're taking a picture of a scene, and you're excited, you want to share it with your family members, your friends, and you send it through basically text-based messages or iMessage or WhatsApp or Facebook and so on. And when we talk about 20 megapixels, it's really big. And when you want to send it, 20 megapixels, if you send only 10 of these pictures, then it would be 200 megapixels that you're sending. This is huge, and it's going to take a lot of bandwidth. You don't want to do that. So the way you're going to do this, you're going to compress it. And the way you're going to, there are many, many, many ways of compression. And I'm just going to explain to you one simple compression technique. Here is my original pixels. So this is an image, and this image, I would say, what is that? 3 and 3, 6 and 2, 8, 8 by 3 and 3, 8 by 8 is 64 pixel. Isn't that funny? 64 pixels versus 20 megapixels. But this makes it easy for us to explain it. So the way we are going to do it, we want to compress this. We want to compress 64 pixels into 6 by 6 36 pixels, okay? We are going to have a filtering process. So this is my filter that I'm going to look into. So what does that mean? It means that take my 3 by 3, map it onto the table that you have. I want you to imagine that I'm going to map it just on the first 3 column, 3 row, 45, 60, 98, 46, 65, 98, 47, 65, 96. You see, 3 by 3. Then I have my filter, which is 3 by 3. I'm going to overlap them on top of each other and then multiply and add them. And as I add them, I'm going to come up with a number. So this is the outcome of a process that has been the application of or multiplication of this matrix of an equal size matrix on that. If you take a look at this matrix, what is it telling you? It says, listen, I don't want you to magnify everything equally. I want you to only magnify the point in the middle by a factor of 2. You see, that's quite different approach. It is compression, but also it is actually manipulating the signal, and in this case, the image. And it is actually magnifying only the center of this matrix. So 45 times 0.1, 60 times 0.1, I'm adding them. 98 times 0.1, 46 times 0.1, 65 times 0.2, 98 times 0.1, 47 times 0.1, 65 times 0.1, and 96 times 0.1. And these are the numbers that came in. I simply multiplied these two matrices and added the component, and the result is going to be 69. Okay, now I'm going to move my window, my matrix. This time I'm going to focus on the next 3 by 3 matrix, 60, 98, and 127. 65, 98, and 123. And then 65, 96, and 115, a 3 by 3 matrix. And I'm going to multiply it by this matrix, and the result is going to be 95. I'm going to move this 3 by 3 window or matrix, and I'm going to move it horizontally, and I'm going to finish everything, and I'm going to get my number, which is 132, okay? Then I'm going to come down by 1 row. The next time, 46, 65, 65, let me actually try this, 65 and 98, 47, 65, 96, 47, 63, 95. Once again, I'm actually magnifying the center point, and the center point is here. Then that's going to give me 68. I'm going to move my window, and that's what you get here. This is a kind of a green color now, and this window is supposed to be multiplied by this, and it's going to get you 92. This window is going to move by 1 column at a time, 3 by 3 all the time, and it's going to be in the same number of rows. You go here and you multiply, and you get me up to 132. The next time you shift your process a little bit down with another row, you start from 47, 60, and then you're going to be here. So this is the 3 by 3 that I'm referring to, and that's going to give you 66. Remember, this is going to actually be different. Depends on it depends on the way you move this matrix. Your outcome is going to be different. Are you moving it this way? Are you moving it this way? Are you moving it on diagonal? What is your plan? The way you move it, the way you actually introduce this matrix is going to have an impact at the outcome. But the result is a simple introduction of compression. You could potentially compress this even more. If your 3x3 becomes 4x4, then this is going to be reduced a little bit more. And that's going to be the type of signal possibly you want to send to the other side. What do we do? We actually transform the data. We transform the image. This image, the original image that I forgot to put here, has been transformed to different types of images with less of a complexity and so on. Now, this was the main part. The rest of the slides actually have quite interesting information just to get you familiarized with the process. Take a look at this. I have another image here, and then I actually potentially I have done filtering. Sometime I intentionally go and add noise to the picture. So these are a noise. We call it white noise. We call it pepper noise. We have different types of noise. And then if you apply this kind of a filtering, you get no noise here. What happened? By doing different types of filtering, you could magnify the noise or you could eliminate the noise, especially if you have a low pass type of a filter, then these are going to vanish, because as you put them into a 3x3 matrix, as you put them into a 5x5 matrix, you're going to average them out. And when you average them out, any sudden pixel is actually going to be to vanish in the process. And you can see, I don't see any dots or noise here. But at the same time, keep in mind that this image is not as sharp as its original image. That's what I'm saying. This image processing is not a single course, is not one or two slides I'm showing you. It is actually a huge field of study, and you could potentially go and learn them on your own. There are many things you could potentially do with image. We have image segmentation, we have image classification. In images, we are going to look for different sets of information. If you take a look at this, for example, I'm going to actually take a look at many many pieces of information that is going to come at me. This is supposed to be wall structures, I would say. This is supposed to be a street. But remember, you are a human. And the reason you say this is a street, because you're a human, you take a look at the picture. You are not supposed to convince yourself that the computer thinks like you. No, the computer does not think like you. The computer only executes what you tell the computer to do. Even when we talk about neural network and all that amazing stuff that we are going to discuss shortly, it's actually you telling the computer what to do. So the computer is actually under your command. So when you say this is a road, computer doesn't understand that. When this is a pedestrian, we don't understand as a computer. This one is a human being. No, you could potentially say this is a human being, this is a human being. And is this a human being? This one? This picture, little picture? No, it's not, right? The reason you say that, because you're a human being. You're an intelligent and smart person. And that's why you're actually seeing this as a non-human being. And you identify. Now, the way you need to do it, when you play with the image is actually depending on the type of the filtering and processes that you apply on the image. Some of the information could potentially be elaborated. You can see these two. You can potentially do the clustering. This is a pedestrian. You could potentially tell the computer how to cluster them. And this is a car. This is the air. I don't see this is a tree. Yes, here is the tree, but I think this is wall, right? Keep in mind, I'm a computer, and this is another wall, right? And this is perhaps a door. Is that a door? It's not. It's just an edge. So I'm trying to alert you that there are things you can do that you actually can grab some of the very specific features of an image, and you can process the signals, the images that are coming at you. For example, we spoke of clustering. Segmentation is one way of clustering. You need to initialize the cluster center, anything, and then assign observation to the closest cluster center, revise cluster centers as mean of assigned observation, repeat step 2 and 3 until convergence is happening. So This is a simple way. You could potentially have center of gravity. We spoke of that before, the k-means method in the past. And then you're going to have some means of observation. We talked about Euclidean distance, for example. We're going to talk about distance in the next series of recording. And then you're going to say, okay, and how number of points that you want to do. Remember epsilon we talked about, as well as the number of points you have, and eventually you're going to separate them. So if you take a look at this, the way you still need, even though you have applied some technique to get from here to here, you still need to cluster them. These are supposed to be, these purple ones are supposed to be identifying one object. These brown reddish ones are supposed to identify one object. These green ones, so you need to cluster them. And the way you cluster them, one of the easiest way of doing it is k-means. We spoke of the k-means in the past, and then you can do many things. So basically this is the original image, and based on the k-means, you got potentially you got only fewer number of colors instead of such a elaborate apple. You could potentially have, still you can identify. So if you wanted to just count the number of apples, you don't care about the color. You want to count the number of apples. So you want to say how many. This is enough. And this is a simple transformation of the data. And you can potentially count the number of apples you have here. But at the same time, when you do these processes and you get from here to here, you need to be sure that this is an apple, this one. That's a challenge. Yes, 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 you're human. You can tell me this is an apple, but is this an apple? You have a lot of work to do for that, right? We basically can apply that to many of the images, handwritten notes, and basically we have interesting stuff that we have put on the slide. And as a matter of fact, much of the image processing contents, I had to remove them from the slides, and just to make this slide suitable for an entry-level student or the high school graduate. But if you are interested, of course, by all means, go and grab more books and YouTubes and lectures and Coursera and all that to familiarize yourself with the image processing algorithms and techniques. But at the same time, the follow-up courses are going to be handing you more knowledge, more information, more expertise, so that you can potentially consider image processing as one of the skill sets in your basket of skills you have on your resume. With that in mind, we are going to conclude for now session 6. Additional information may be added later, but this is going to be sufficient for us at this time. And session 6 is going to be concluded now. Thank you very much. See you for session 7.